Our last objective for this lesson is to interpret a function graphically, and we're going to be putting together everything that we've covered so far in this lesson. For part A of this example, we want to evaluate f of negative 3. If you remember, I think it was our second objective. Yes, we saw, for instance, right here, this notation, f of negative 3. It means plug in negative 3 for x, and our answer is whatever the y value is. So just coming back to this example, we got that f of negative 3 was equal to 28. That means that the point negative 3, 28 is on the graph. When we plug in 3 for an x value, we got out 28 for a y value. Let's go apply that here. So if I were to plug in negative 3 for an x value, I would go here to negative 3, and we need to know what y value do we get out. Well, at negative 3, we can see the point negative 3 on the graph. So when x equals negative 3, y equals negative 3. So f of negative 3 is equal to negative 3. This is the y value that we got out when x was negative 3. Let's see what happens when f is 0. When x is 0, when x equals 0, what y value do we get out? Well, when x is 0, I can see this point that looks like it's I'm just going to say that's about 0, 2. So when x is 0, y equals 2. So f of 0 is 2. When we plug in 0, we get out 2. What happens when we plug in negative 1? Well, here's negative 1 right here. We have to choose. Do we choose the open point up at 1, or do we choose the closed point down at negative 1? Which y value corresponds to x being negative 1? We choose the closed point. Closed means included. Open means excluded. So when x is equal to negative 1, y is equal to negative 1. So f of negative 1 is negative 1. That's the y value that we get out. Part D, we shift gears. They ask us to find all x for which f of x is equal to 3. F of x equal to 3, f of x is the y value, where y is equal to 3. So here is when y is 3. And we can see we have a point right there where y is 3, and then we have a point right here where y is 3, right? If I were to draw this line, y is equal to 3, that touches the graph twice. So at what x values, for which x values does that happen? Well, it happens at the x value of 1, and it also happens at the x value of, if this is 2, this is 3, let's say that's about 3.2, let's just say that's about 3.2, and I'm just approximating that. So at those x values, the value of the function is equal to 3. Let's do the same thing where we find the x values for which the function value is 1. Well, if the function value is 1, the y value is 1, so I'm talking about here, we will not include that open point because open means excluded. So we will not say negative 1. We will not say that that's an answer. That would be wrong because that's an open point. But when y is 1, when the function is 1, when y equals 1, that's what f of x equal to 1 means, we can see that we do have a point at 2, 1. So for the function to be 1 means that x was equal to 2. And that's our only answer there. We will not include negative 1 because that is an open point. Next, we want to find the x-intercept. This graph never touches the x-axis, right? We can see that the graph never touches the x-axis, so there is no x-intercept. Let's find the y-intercept. Where does the graph touch the y-axis? That happens right there. That is the point 0, 2. Remember, intercepts are points. I think your homework will want you to just put in 2, but your homework would count 2 correct. I would not. It's just the way the program is coded in the computer. Intercepts are points. It's the point 0, 2. The last two parts, going back to our previous objective, we want to find the domain and the range of this function. For the domain, start on the x-axis from the left out at negative infinity and work our way to the right. This arrow means this piece continues on forever. From negative infinity, we would be able to see that in the function. So the domain does start at negative infinity. We continue along the x-axis until we get to negative 1, where we have to make a decision. Is it included or excluded? And it is included because we do have a closed point there. So we will continue along the x-axis onto infinity because this piece continues to extend out. right? As we're here and we're looking up and down, walking along the x-axis, we are seeing the function when we look up. And we will continue to see it as we move towards positive infinity because of that piece that's continuing to extend outward to the right. When we're talking about domain, you have to think about right and left. For the range of this function, we're going to start at the bottom, down at negative infinity on the y-axis. When we look left and right, do we see the function? Yes, we see the function when we look left. So the range is starting at negative infinity. As we continue to move up the y-axis, as we look left, we continue to see the function up until we get to -1. Past -1, in between here, what I'm shading in orange, as we look right and left, we're not seeing any of the function. So I'm going to say that the range goes from negative infinity to -1, and I put a bracket on that -1 because this point is closed. I do not see the function again until I get up to 2, right? You may say, oh, but that point's open right there. Well, that's fine, because if I look right, that's closed. That's included in the function. So the range does pick up, the range does pick up again at 2. So I'm going to union this with 2, and I'm putting a bracket on 2 again because of this here. That is included. And then as we continue to move up the y-axis, we will continue to see the function onto positive infinity because this piece continues to extend upward. When we think about range, we have to think about bottom to top. And so that completes our final objective for this lesson.